Actually, I can tell you once I get this set up, I'll tell you what it does. So this instrument measures what is happening in the water every 1/10 of a second all the way down to the bottom of the lake. So it's measuring parameters that actually affect how deep we can see the Secchi disk. So that's why we use this equipment, and then we take the data back and we figure out, okay, why was the Secchi reading the way it was today? All right, I'll tell you a little bit about this one before I hook it up. The water flows through as it drops to the water column, and it's measuring particles in the water column. So it measures both the silt that's in the water, but also the algal cells that are in the water, and it bins them in different size ranges. The particles that do the most detriment to water clarity are between 1 and about 5 microns in size, so very small. So the more of those you have, the more light scattering there is. The light doesn't penetrate as far, so you can't see as deep into the lake. All right, the moment you've all been waiting for, the Secchi disk.
This is our Secchi disc. So it's a 10-inch wide white plastic plate. And we're going to attach it over here and lower it over the side of the boat. We always want to do it on the shadowed side of the boat. We also do it at solar noon, so we're doing it at this kind of peak sunlight overhead every day. When we do it, we remove our glasses. If we do not have 20/20 vision, we put on prescription lenses to correct that. And we usually have 2 people do the Secchi reading to make sure that everything's kind of consistent.
So this is our zooplankton net, and zooplankton are the small, near microscopic organisms that are out in the lake, the animals that are eating the algae and the fine particles, but they also pick up the silt and the clay, so the inorganic particles that are in the lake. And we're going to send this down to 150 meters, bring it back up and see what zooplankton we have in the lake. So some species are better than others at eating the fine particles. Because they're so good at filtering those out of the water, they can have an impact on water clarity. Tahoe buoy number 1.
So this is Tahoe buoy 1. Up top we have a bucket that we switch out about every 10 days. It collects the nutrients that are falling on the lake, so nitrogen and phosphorus that's falling out of the atmosphere. So we call that atmospheric deposition. And nitrogen and phosphorus are basically algae food. So the more nitrogen and phosphorus you get in the water, the higher algae growth you might get. Give me another 5 or 10 minutes for next week. Okay. All right, so we're at Tahoe buoy 4. Up top there we have a large metal bucket, and that captures particles that are falling onto the lake. So particles are super important when we're talking about water clarity, because those really small particle sizes can really impact light scattering and how far down you can see the Secchi disk. We'll run this back in the lab and analyze what different size classes there are of particles and how many there are of each of those different size classes.